Welcome to this edition of Models to ACE, presenting an Excel spreadsheet-based simulated model to predict the end date of a project in the most likely, the less likely, and the unlikely scenarios. Let us walk through the sections in the spreadsheet. This is the first tab titled AON Graph in the spreadsheet. This is the tabular form of representing the activities in the project, the dependency relations among those activities, and the duration of the activities. This activity on node diagram gives a visual representation of the project. This is the second tab titled Duration Simulation in the spreadsheet, which houses the simulation model. This is a copy of the same table with details of the activities. The column C, however, contains cumulative probabilities. This cell is used to simulate chance. Based on this random value, the actual activity duration table receives actual values for duration of each activity from the model. Observe that without this simulation, we would have to evaluate the exhaustive set of 90,000 possible scenarios. Finally, this is the third tab titled Project Duration Analytics. Simulation allows us to generate a convenient sample and base our analysis on that instead of the population of 90,000 possible scenarios. Here we invoke the model for a predefined number of times to generate large sample sets and perform analytics on the data to derive insights. This section of the model produces useful insights about the project by automating repeated simulation of the model and measurement of its output. The first tab titled AON Graph consists of the table to the left and the directed graph to the right. On to the left, the table named AON Table lists out the 8 activities in the project along with data on those activities. This data is the input to the model. The project is visually depicted in the graph to the right. This graph represents activities on its nodes connected to predecessors by directed arrows. Let us walk through the sections in the tab titled AON Graph. On to the left, the table named AON Table lists out the 8 activities in the project named A through H in the first column. The project is visually depicted in the graph to the right. Data regarding activity or node A in the graph is available in the table rows 3 through 6. Similarly, for activities B, C, D, E, F, G, and H, 2 dummy nodes labeled Start and End are inserted to indicate the terminal extremes of the network of nodes. Start indicated day 0. Activity A, being the first activity, has no predecessor. Activity B is preceded by A and can start only after A has completed. This dependency is visually depicted by the directed arrow originating from node A and terminating on node B. Activity E has 2 predecessors in B and C. Thus, activity E can start only after the later of the end times of B and C has elapsed. The last column of AON table lists out the range of closely related possible durations of each activity. The duration of each activity is not a fixed, predetermined number of days. Rather, we have a range of likely values mapped in column D against the corresponding activity. Each possible value has a corresponding probability of occurrence, indicating its likelihood. These are specified in column C. For example, activity A can last for either 4 days at a minimum or 5 days or 6 or 7 at most. This implies that activities B, C, and D can start only after either 4, 5, 6, or 7 days have elapsed since the start of the project. Similarly, activity B can last for either of 13, 14, 15, 16, or 17 days. 90,000 possible combinations of activity values exist for those listed here. The third column of AON table lists out the corresponding likelihood of occurrence of each of the possible durations of an activity. Thus, for activity A, there is a tiny 5% chance of it being completed in 4 days since it begins, a fourth of likelihood that it will get completed in 5 days, and an equal likelihood of 35% for durations of 6 and 7 days. Observe that for each activity, these probabilities add up to a total of 100% or unity, since the duration values represent an exhaustive set. The tab titled Duration Simulation contains the model that takes the input data we have supplied regarding the activities. We have reproduced the activity table on the left. However, the individual probabilities for activity duration have been replaced with the corresponding cumulative probability ranges. We use a random generator to simulate chance. The table named Actual Durations is the model. Based on the random value generated, it generates actual values for the duration of each activity and derives its end time based on its precedence relations. The end date of the last activity H is computed similarly by the model, and this also represents the end date of the project. Assuming the project start date is day 0, since the possible durations for activity A range from the lowest value of 4 days to a maximum of 7 days, a plot of the probability distribution of these duration values would show that the value 4 has a range of probabilities between a lower bound of 0 and a ceiling of 0.05. The possible likelihood for activity B starts from the corresponding upper bound for value 4, namely 0.05, and the upper bound of 0.3, obtained by adding its probability 0.25 to the lower bound 0.05. Thus, column C represents the lower bound of the range of probability of each activity. Obviously, the upper probability bound of the highest value for duration is unity. Thus, for activity A, the value of 7 has a range of probabilities between the lower bound of 0.65 shown alongside value 7 and the upper bound of unity. The duration values and their probabilities are arranged as shown to facilitate VLOOKUP when the model constructs the table of actual durations based on random chance value.
The random chance value generated is 0.86, shown in cell H1. Looking at the cumulative probability column corresponding to activity A, the model picks the corresponding value of 7 to generate the value for actual activity duration, column H, for activity A. This is how the model constructs the third column in the actual activity duration table. Since A is assumed to start on day 0 and last for 7 days, it ends on day 7.
Based on the chance value of 0.86, activity B is expected to last for 17 days. Since B can start no earlier than when activity A ends, that is day 7, it is expected to end on day 24, which is the sum of 7 and 17. Similarly for activities B and C. Let's take a look at activity E. It can start only when its predecessors B and C have completed. In other words, E has to wait for the slowest or latest of B and C to end, which is day 24 as simulated by the model. Once started, it will last for 9 days and end on day 33. Similarly for activities F and G.
This is how the column named Actual End Time is generated by the model. The model predicts that activity H will end on day 46 based on that of its predecessors E and G. Since H is the last activity in the project, its end date also indicates that of the overall project. This is captured in cell I16, labeled Project Duration in Days by the model.
Insights that can be derived from this model can be constructed in the last tab for Project Duration Analytics. This is the most significant output of the model. Here, a data table auto-generates sample of possible values of the duration of the entire project as simulated by the model in the previous tab. We derive descriptive statistics, minimum, maximum, mean and standard deviation of the sample. Based on these, we automate the construction of the probability distribution function of the project duration values. The probability distribution is visually depicted on a graph.
Suppose we want to generate 1000 possible project duration values in cell I16 using this model and create a table of these values. We automate this model invocation and recording the output value using Excel's data table function. The possible values are recorded in column B as highlighted. To do this, we use a sequence of 1000 numbers obscured in column A by using the same font color as the cell background. Let us see how this table can be constructed afresh. One row below the cell B2, where we reference the output value of the model, key in the starting observation sequence, number of 1 for the sample. Use Excel's automated series generator under Home tab Editing Fill to generate a sequence of 1000 numbers along column A starting from 1. Select this entire range in the table. Under the Data tab, go to What If Analysis, open Data Table. Since our model automatically generates output values based on activity data, we need not pass any row or column inputs to the data table. However, for semantic purposes, we supply a dummy input to the column input cell by pointing it to a blank cell such as A2. Observe that the data table has performed 1000 iterations on cell B2 and recorded its values in column B. We generate the descriptive statistics for this sample of 1000 simulated values under columns D and E. Note the array data table that is passed to Excel's min function here. Data table is the name we have given to the array of 1000 data table generated values. Such naming is useful for avoiding hard coding the range and avoiding errors due to Excel's autofill function. We will need the min and max values to generate the range of possible project duration values in the next table under columns G and H. Since the sample values range from a minimum of 31 to a maximum of 46, we tabulate these values under column G. To do this, we use an obscure column F of 459 serially generated sequence numbers. This is generated using the same method we used for column A. However, we generate only 459 values this time. In the first row of the table, point cell G4 to the min value from the table on descriptive statistics. From cell G4 onwards, increment this value by 1 till the value max is reached. The model thus constructs the range of possible values from 31 to 46 based on the data table generated sample. Not all of these values may be present in the sample. This is evident from the percentage counts of occurrences under the likelihood column, column H, where 4 occurrences of 0% indicate that the corresponding project duration values never materialize. Thus, the project is most likely to last for a duration of 37 or 40 days with equal likelihood. Durations such as 31, 34, 36, 37, 41 or 44 days are less likely, while durations such as 32, 33, 39, 43 or 45 are unlikely. The model is intelligent enough that it does not generate any values under column G and H beyond row 19 with a duration value of 46. This is despite the obscure column F having sequence values stretching much beyond this range till 459. The line chart in columns I through Q is based on the project duration distribution table. This is a 2-period moving average trend line plotted based on the table values.
Thank you for giving Models to ACE the opportunity to serve you with our analytical models. Please subscribe to our channel.